Hello and welcome to this mini masterclass video. My name's Tim and I'll be applying my experiences as an education consultant, examiner and ex-head of science in helping you to secure knowledge of the facts and how to apply these effectively to your exams. I'll share lots of hints, tips and common errors to watch out for along the way. Let's get cracking. So we're looking at calculations in chemistry. This is part one where we'll be focusing on relative formula mass, MR, and percentage composition by mass calculations. We will of course need a calculator for this. Do not worry, no matter what specification you are studying, this is applicable to all. Just to point out though, most of the questions I use today will be from AQA and Edexcel exam boards. So let's secure the knowledge of what relative formula mass is and how we calculate it. So essentially, it's the sum of the relative atomic masses of all of the atoms or ions in a molecule's formula. Now, in this scenario, we're going to look at water, formula H2O. We've been given the relative atomic masses there, the AR standing for relative atomic mass. H is 1 and O is 16. If we weren't given those, then we could obviously get them from the periodic table, looking at the big number next to the symbol. As this is the first question we're looking at, I've included a very basic particle diagram there on the right hand side for water. The mass is shown in each circle for each element. Step one then, we're going to list the symbol of each element and the number of atoms of each element as dictated by the formula. So because there is a little 2 after the H, that tells me there are 2 atoms of hydrogen. There is no number after the O. That tells me there is 1 atom of oxygen. Remember, a molecular formula will not have a 1 after a symbol. If there's no number, assume there is 1 atom. Step 2 is to multiply the number of atoms by their relative atomic mass. So because I have 2 atoms of hydrogen, I'm going to multiply it by the mass of 1. And because I have 1 atom of oxygen, I'm going to multiply it by the mass of 16. The final step is simply to add those together, giving me a total of 18. If that is difficult at this stage for you at home, then if you look back at my little particle diagram, you can see if you add those numbers together, it's going to give me my final total of 18 as well. So in an exam context then, I'm going to do this one. I've been asked to calculate the relative formula mass of calcium chloride. I've been given those relative atomic masses in the question, thanks very much, and it's only worth 1 mark. So I know it's going to be a basic calculation, but nevertheless, still show my working out. I start off by listing the symbols and the number of atoms of each element. There is no number after the Ca, so I know there's 1 atom of calcium, and there's a 2 after the chlorine, so I have 2 atoms of it. I then multiply each by their relative atomic mass, again, which is given in the question. I then add those values together to give me a grand total of 111. I'm going to do a quick glance back to make sure that I've assigned the correct relative atomic mass from the question to each symbol. I'm happy. I'm going to move on. Right. I've got 2 here for you to have a go at home. I've made them into multiple choice questions at this stage just to give you a little bit of help, and I've also included an examiner's tip for the last one. Pause the video and then we'll review the answers in a moment. Okay then, for the first one we should have got an answer of 40. Again, if you were struggling, a little particle diagram to go alongside that is shown on the right hand side, and obviously again if we added those together we'd get an answer of 40. Now for the second one it was worth 2 marks, so well done if you spotted that at home, and the reason it's worth 2 marks is we have been presented with our relative atomic masses for each of our elements in a different order to which they appear in the formula, which is why my examiner's tip was to watch out for the ordering. Okay, some of you, if you did this very quickly without checking, may have gone for 83.5 by mistakenly multiplying the first number by 1 and the second number by 2, when in fact it's the magnesium that is represented first. So there is 1 atom of magnesium, so 1 times 24 added to 2 multiplied by 35.5, giving us a grand total of 95. There again, simple particle diagram. So, slightly more challenging one here. I'm going to again do this one where I've been asked to calculate the relative formula mass of aluminium carbonate. Oh dear, I have brackets. This looks a bit more tricky. It's worth 2 marks. So I know it's going to be a little bit more challenging than the first one I did. Let's have a look at how I'm going to go about doing this. So interpreting the formula. That 2 tells me there are 2 atoms of aluminium. Now the numbers inside the brackets, like in maths, are multiplied by the number outside the brackets. So since I have 1 atom of carbon inside the brackets and a 3 outside, 3 times 1 tells me there are 3 atoms of carbon. Oxygen has a 3 after the symbol. Multiplied by the 3 outside the brackets gives me 9 atoms of oxygen. Now, I'm not suggesting you draw this in your exam. This is just for a little bit of support at this stage so you can see what that molecule actually looks like. Following the steps from earlier then, I list the symbols and the number of atoms of each. I multiply the number of atoms by their relative atomic masses. And then I add them all together, giving me a final total of 234. Your turn then. We have 4 marks worth of questions for you to have a go at home. That means you should spend no more than 4 minutes on this. Pause the video and we'll review the answers in a moment. Right then, for the first one, we should have got a final answer of 62. And for the second one, we should have got a final answer of 164. My working out there is shown for you if you made any errors. Percentage composition by mass. This is the second part of this session. Let's secure the knowledge to begin with. Essentially, we're working out the proportion of the total mass of a compound for a particular element. Now in mathematics, one of the earliest formulae you'll have been taught for percentage calculations was likely in this format. Part divided by a whole multiplied by 100. We're going to do exactly the same, but in a chemistry context, by doing the mass of all of the atoms for the element posed in the question, divided by the relative formula mass of the compound multiplied by 100. So we are being assessed on our skill of relative formula mass calculations as well when we do this. Exam context then, I will do this one. So I've been asked to calculate the percentage by mass of aluminium in aluminium chloride, and I need to give my answer to 3 significant figures. I've written out the equation for now that I'm going to apply to this. This was from the previous slide. And the first step again is to calculate the relative formula mass of aluminium chloride. We've seen how to do that earlier on. I then calculate my percentage of aluminium by doing the mass of all aluminium atoms, and since there is only one of them, I'm using 1 times 27 is 27 divided by the relative formula mass multiplied by 100 to give me my percentage. And since I've been asked to give this to 3 significant figures, I'm looking at my third value here, the 2 after the decimal point. And since the 4th number is less than 5, I'm going to round down, leaving this at 20.2%. One for you to consider then. We've got an example student's answer in purple there. I'd like you to have a look at that and think about how many marks that student would get out of 3, and I'll review the answers in a moment after you've paused and had a go at thinking about how many marks that's worth. Right then, so 2 marks would be awarded, 1 for the correct calculation of relative formula mass, and the second for their correct percentage calculation. The student has done well by noticing that there are 2 atoms of lithium, so they've multiplied 2 by 7 to give them 14 for their total mass of all lithium atoms divided by the relative formula mass multiplied by 100, but it asks for 3 significant figures, not 4. Since the fourth value was a 2, then the final answer would be 12.7. Okay, we would round down in that case to 12.7. Final one then for you to have a go at. It's worth 3 marks, 3 minutes. Pause the video and I'll review the answers in a moment. There's our relative formula mass of sodium nitrate, 85, 1 mark for that. There's our percentage, 1 mark for that, and our 3 significant figures. Well, in this case, we're going to need to round our 0 up to a 1. 27.1 is our final answer. 3 marks for 27.1 if you got it. And that's a wrap. So, relative formula mass and percentage composition by mass calculations in chemistry, those are both boxed off. If you found this useful, please do hit the like button. For more mini masterclasses, please do subscribe to my channel, Science Mini Masterclasses, and I'll see you in the next one.